Hello, all. The problem today we're going to solve is called as sort colors. It is on lead code under the medium tag, and the problem statement goes like this. We are given an array nums, and it consists of three objects: red, white, and blue, and they're represented by integers 0, 1, and 2. So, and we are expected to sort them so that same colors are adjacent with colors in order of red, white, and blue. So you can see that result has to be in such a way. So we can boil down this problem into simply we're given an array of numbers, we have to sort those arrays, right? And the catch is that they are zero, there are only zeros, one, and twos, right? And we cannot use any sort algorithms, sort inbuilt functions, and we are asking us to perform one pass algorithm, and we have to sort them in place, right? So we have to use in place algorithm, right? So let's understand the algorithm. And before that, this problem is called as there is a this problem is popularly known as Dutch national flag problem. So this is simply, if you observe the Dutch flag, right, there are three colors in the Dutch flag. So this is where the problem name comes from. Okay, let's understand how the algorithm works. This is a given array, and we can perform any other sorting algorithm, right? But that's not the point of this question. So the point is, the question is, we know what are the objects present in this array. So we have to somehow take advantage of that and perform in place algorithm. So we can take advantage of that by performing such a way. So the main point of this problem is, we know what are the objects, right? So we know there are only three objects. So if we are able to sort, or if we are able to arrange two items, right? So if we are able to arrange zeros and twos, then automatically ones will be arranged, right? So let's say if there are three persons and they have to be arranged in a proper row. If you can perform two swaps, or if you can arrange two people in the right positions, right? So automatically the third people will be in his position, right? So this is what we're going to take advantage. So for that, we're going to use a two pointer approach. So one pointer one is going to help us sort zeros, and pointer two will help us sort twos, right? And we are going to arrange twos to the end, and we are going to arrange zeros to the beginning. So this pointer will start from 0, and the pointer 2 will start from n minus 1, where n being the length of the array. And we will going to perform one pass. So for that, we have an index. This starts from 0, right? And it goes until we have sorted all the array, so until the one pass completes. So in each iteration, what we're going to do, we'll check what is the element at this index. If the index is 2, we're going to put it at the back, that is at the p2th position, right? So if if we are seeing to, number 2, then we know that it has to be at the end. So we're going to swap 2 with element which is at p2th index, right? And in the same way, and after that, we are going to bring the p2th index to p2 minus 1. So we are decreasing it because this portion is sorted. And same thing with p0. So if I've seen p0 right at index, so I'm going to swap it with my p0, because zeros has to be placed at p0. After that, I'm going to again increment this to 1, because this portion is being sorted. After the swap, this portion is sorted. So this is what the algorithm is. So based on that, we are going to solve the problem. Let me just code it up so that we can understand it a little better. So yeah, I'm going to use VS Code for coding this. I will copy this. So yeah, so we have our sort colors, and it's going to take nums as its array. And yeah, so let's say n is equal to length of nums, right? And so we're going to initialize our pointers, p0 and index. They both are starting from 0, and we have p2 pointer, it is starting from n minus 1, right? So let's perform a while loop, and the loop will one pass will continue until all the elements are sorted. So all the elements will be sorted, and the index will reach to the p2th index, right? So this would be enough, because we know that till point p2 everything is sorted. So if our index is reaching p2, then we know that all the elements are sorted. So we have three conditions. One is if nums of index. Wait, so we have three conditions. What if nums of index is equal to 0? So yeah, what is that? What if it is equal to 0? So we know that we have reached this point. So in this case, we are going to swap it with p naught index, because the position of 0 is at p naught with p. So whenever we reach 0, right? So we are going to make a swap with p naught pointer, because p naught pointer represents the position of zeros. So this goes like this. So we are going to swap nums at index and nums at p naught, nums at p naught, comma nums at index. Right, this is a simple swap, and now the index is going to be updated by 1, and in the same way we're going to update our p naught with 1, right? And we'll simply continue out of this loop. So what if the condition is like this? So what if the index is equal to 1? So since we are not sorting or anything with the 1, right? So we are going to simply move our index to 1. And what if the condition is what is if the condition is what is the remaining condition? What is if it is third color? So we know that the point of so the position of this 2 has to be represented by p2, right? So we are going to perform the same swapping, but in this case the swapping will be done with pointer p2. And once the swap is done, we are going to decrement the p2 pointer. True. Now if I return nums, let's print sort colors, and it's going to take let's run this. Yeah, okay, so there is some error here. Yeah, we have missed our continue, right? So once it is done, so we have to come out of that. So now it is done. Let's copy this code and paste it here. Everything needs one line of indentation. Yeah, looks good. Do we really need to return this? Let's wait. Let's see. I don't think we need to return this since we are performing in place, right? Okay. So this is a in place algorithm, right? So we don't need to return. Yes, we don't need to return this. And let's see how good our algorithm does. Yes. So, so our algorithm runs at 80 milliseconds, which is very fast. And as I always say, no, never look into this ratings. See, previously we were beating only 5-6%. Now we are beating 99%. So anyway, we are performing the algorithm by using in-place sorting, and we are using constant space. Yeah. So I hope you like this video. If you like the video, and give it a like, and consider subscribing to the channel. And yeah, we'll see you in a new coding video. Thanks for watching.